This conference will now be recorded.
So, good evening, very good evening, dear students. Today, we'll be completing this wave optic chapter. We have picked up a few questions on polarization part from various exams like NEET, AIMS, and JEE mains. So, this particular problem, it is from IIT JEE, May 2018. So, let's see what is this problem. So, question says, unpolarized light, excuse me, the passes through an polarizer A. Another identical polarizer B is placed behind B. Sorry, behind A. B is found to be I by 2. Now another identical polarizer is placed between A and B. The intensity beyond B is now found to be 1 over 8. Sorry, I over 8. Then the angle between polarizer A and C is 0 degree, 30 degree, 45 degree, or 60 degree. So you have to find out the correct angle between A and C. So this problem, as you can understand, so is Mallows law. Okay. So as we solve this problem, we'll discuss first what is Mallows law. Let me tell you, this problem is from Mallows law, and sorry, Mallows law, and maximum question I have picked up on this from various exams is based on this Malus law alone. Okay, this Malus law and Booster's angle. So these two things are important for like these two things are actually important in polarization. One is Malus law, another is Brewster's angle. Okay, Brewster's angle. So these two things are important in this polarization. Things this are in this way. First discuss, since this problem is discuss Malus law little bit. Malus law. See if polarized light in, in all directions, electric vector. Okay, so generally the electric field in two directions, in plane perpendicular direction is covered plane. Then so this light, this is unpolarized. Now when this light is passed through a polarizer, see or an polarizer, polaroid, polarizer or a polar has their axis, path axis, path axis in so then and perpendicular path axis of toroid A is perpendicular direction. This is x direction. Then see from y direction, then only the electric field vector will pass. That means you will get only the which are parallel to this mark of the electric. So only this vibration polarizer will pass through, and the one which is what is perpendicular will actually get cut off. So this will see vibrations perpendicular direction. All the which are in the parallel direction will be cut off. That means what? Half of the light vectors or electric field vectors are half of the electric field vectors are cut off. That's why if the intensity of a polarized light is I, then here must be I by 2. Okay, so this is first part. Now second part is that if another polarizer is kept and which has path axis, suppose this is another polarizer B which has path axis in a direction which makes an angle, or the path axis of B makes an angle theta with the path axis of A. That means, see this polarization now, so this is the path axis, okay, this is path axis, and this is the electric field vector, and this is the angle theta. So if this is I0, so I0, sorry, I0, or here it is I by 2, then after passing through this B, the intensity will be I0 cos square theta. That means whatever intensity was earlier, like this is the initial intensity, this will be I by 2 into cos square theta. So this is the Malus law. Like how much, like say if this light is passing through many other polarizer like this at different angles, then you have to follow this initial intensity. Okay, like this is initial intensity is this. In this case, it will be I by 2 cos square theta. If I keep another polarizer like this and with some other angle phi, then what I have to write after this? See, I by 2 cos square theta, and another will come. This is that this has initial intensity. Then you have to write, if this angle is phi, then it will have it, you have to write cos square phi. So this is how the intensity will be according to Malus law. So according to Malus law, intensity after passing through a polarizer which is at an angle theta with respect to the electric field vibration, okay, or electric field vector. So intensity will be initial intensity I0 cos square theta. Okay, if you pass this output through another polarizer which has path axis making an angle phi, then you have to multiply cos square phi. If you pass this again through some other polarizer which has path axis making an angle some beta or whatever, so again cos square beta will come. Okay, this is how you have to solve or use the or apply the Malus law. Now look, in this problem, unpolarized light having intensity I passes through an ideal polarizer, and another identical polarizer B is kept behind it. The intensity of the light is found to be I by 2. What does that mean? That means these are identical polarizer having the pass axis. These are pass axis having the pass axis orientation along the same direction. So that's why if you have unpolarized light here, unpolarized light here having intensity I, so one like vibration in one direction, electric field vibration in one direction gets passed through. Okay, that you can understand here. So this will be I by 2 intensity. Since these two polarizer has identical pass axis, okay, they are identical first of all, and their pass axis are actually oriented in the same direction. So that's why there will be, see, uh, there will be, if I write this I 0 by 2 as initial intensity, then it is cos square 0 degree because angle is 0. So what you get? You get this as I 0 by 2 only, okay, or I by 2 only, okay. So if the path axes are parallel, then there will be no reduction in the intensity. The intensity remains the same. So that's why intensity is seen to be the same I by 2. So that is what is told up to here. Okay, so B is kept behind A and intensity is found beyond B is I by 2 because these are identical and their path axes are also identical. Now see another polarizer, identical polarizer C is placed between A and B, but this time the intensity is seen or found to be I by 8 beyond B. Beyond B, we see the intensity I by 8. I by 8. Okay. Look, what does this mean? See, if I keep another identical polarizer, this time here the intensity is found to be I by 8. Okay. Then what is the angle between A and C? What is the angle? Angle between the polarizer. Angle between the polarizer means angle between the path axis or polarizer also you can say. So what is the angle between this polarizer A and C? So the angle is suppose theta. If the angle is theta, I can write here the intensity after passing through here. What will be the intensity? I by 2 cos square theta. Okay. Now look, since these two A and B has identical path axis, that means the orientation of the path axis in the same direction, vertical direction in this case, then the the light which is passing through this, they have actually electric field vector in this direction, okay, in this direction. That means this electric field vector will make an angle theta degree over here, okay. The electric field vector, the component of the electric field vector which is passing through this C analyzer, sorry, polarizer, that will have electric field vector vibrating along the direction which makes an angle theta with the vertical. So look this, okay, the electric field vector has this. Then we have to find out the component of this. So that's why here also intensity will be, see the initial intensity I have to take this cos square theta and another cos square theta, right? So this is how we can get the intensity I by 8, okay. So if I solve it, see this is cos to the power 4 theta is equal to I by, not I, 1 by 2 as you can see from here. So 1 by 4, sorry, 1 by 4. So cos square theta will be plus or minus 1 by 2. Let us take the magnitude alone, otherwise, like positive alone, otherwise this imaginary number will come. That is not true. So cos theta is found to be 1 over root 2. Therefore, theta is cos inverse 1 by root 2, which is nothing but 45 degree. So I hope you have understood this. So the angle between A and C, and in fact that is the same with B and C also. So the angle between A and C will be 45 degree. Okay. All right. So we'll move on to the second question. See here also, as I said in the beginning, the questions are repeatedly comes like given. Questions are repeatedly given in various years from this Malus law, either from Malus law or from Busch's angle. Okay, so here also the question is from Malus law only. See, an unpolarized light of intensity I0 is incident on a polarizing sheet. Okay, unpolarized light, as I have showed you. So one will have electric field vector like this, another like this. So intensity of the light which does not get transmitted. See, if I say the path axis for this is there, so half of this is actually getting transmitted, and what is not getting transmitted is also half. Okay, also half. That's why. So total intensity I have to take I0. If half get transmitted, I0 by 2. So this is I0 by 2 only. Okay, I0 by 2 is the intensity which does not get transmitted, not the I0. You should not think that that will be I0. No, that is not I0. If this is I0, see, half of the vibrations are passing through, so half will be remaining. Okay, so this remaining or the vibrations or the electric field vector which are not getting through this polarizer or polarizing sheet, they also had intensity half of the total intensity. Okay, that's how. Now see, this question is very interesting. This is from Busch's angle. Okay, so let us first read the question. Unpolarized light of intensity I0 is incident on surface of block of a glass of Busch's angle. Unpolarized light of intensity I0 is incident on a block of glass. This should be at Busch's angle. Okay, at Busch's angle. In that case, which of the following is true? Before we answer, let me read the options. Reflected light is completely polarized with intensity less than I0 by 2. The transmitted light is completely polarized with intensity less than I0 by 2. Transmitted light is partially polarized with intensity less than I0 by 2. Reflected light is partially polarized with intensity less than I0 by 2. Okay, let us see. Actually, this is the option is partially polarized with intensity. This option is with intensity, not less. Okay. See this figure. So when an unpolarized light, see in this case the notation we have used this double arrowhead. This is vibration in the plane of the paper, or and this is the electric field vector which I was drawing like this. Another I was drawing like this, right? This is in plane, I said this is out of plane. In this case the dot is actually electric field vector vibrating in a direction perpendicular to the plane. Okay, so here also you can see so here in unpolarized light, in case of unpolarized light I have two vibrations. One is in plane vibration, another one is out of plane. Okay, so when the unpolarized light incident on the surface of a glass, here suppose this is glass, so this is interface between air and glass. So there will be Booster angle is such an angle, Booster angle is such an angle of incidence when the reflected ray and refracted ray, they will be at 90-degree angle. So this is the speciality with the Brewster's angle. So if the unpolarized light gets incident at the angle of, like at the Brewster angle, then the reflected ray, see you can see this reflected ray, and this is the transmitted ray or refracted ray. These two rays will be perpendicular to each other. Fine. Not only that, at this situation, what will happen? The reflected ray will be completely polarized light. So this is reflected ray, this is completely polarized. That means it has only the electric field vectors which are vibrating in the direction perpendicular to the plane. Okay, so this is completely polarized. Completely polarized. So we can understand that the reflected light is completely polarized from this figure. What about transmitted ray? Whether this is also polarized? Yes, it is polarized, but partially polarized or slightly polarized. Why? Because see, in this direction you have some electric field vectors which are oscillating or vibrating in a plane perpendicular to in a direction perpendicular to the plane. So these are actually perpendicular vibrations of the electric field vector. See, maximum will be in plane vibration, but some are there which are vibrating out of plane. So that's why it is this light, refracted or transmitted light, is partially polarized light. Partially polarized light. Okay. So now read the questions. Reflected light is completely polarized with intensity less than. See, this is fine. Completely polarized. See, another option is there. Reflected light is partially polarized with intensity. This is with intensity. With intensity I0 by 2. So these two options I have now. So which one is correct? Whether the intensity I0 by 2 is correct or intensity less than I0 by 2 is correct. See, if we closely look here, see when I have two vibrations completely separated from each other, then I could say both, say, transmitted and reflected light will have intensity I0 by 2. But in this case, see, transmitted ray has some perpendicular vibrations. Okay, So that's why here the intensity will not be exactly half. It will be less than I0 by 2. Less than I0 by 2. Okay. I am sorry. This option may be all right because it is said partially polarized. If it is completely polarized and with intensity, I can make another. If I write this as completely polarized also, completely polarized with intensity I0 by 2. If I write this also, this is also not correct. Only this is correct. Light which is reflected is completely polarized with intensity less than this. This is correct. Now the transmitted light is completely polarized. See, it is not completely polarized. This is partially polarized. So this is not correct. Transmitted light is partially polarized with intensity I0 by 2. This is also not correct. This is not with intensity I0 by 2. See, partially polarized is fine, but intensity will not be I0 by 2. It will be less than I0 by 2. Okay, since uh, or maybe this may be greater than I0 by 2, maybe greater than I0 by 2, greater than half. Okay, this will be greater than half, not less. It will be greater than half because say half will be with their own vibration and the different vibrations will be adding to the intensity. Okay, so that's why it will be greater than I0 by 2. So that's why it is not correct. Partial is fine. Partially polarized is fine, but intensity with I0 by 2, this is not correct. It must be greater than I0 by 2. Okay. Okay. So I have already discussed this fourth option. So we have got the first option to be the correct. We'll go to the next question. See, as I mentioned before, so questions from polarization will be coming from mostly this Bosch's law and Malus law. So see here also this fourth question, a beam of unpolarized light of intensity I0 is passed through a polaroid A and then through another polaroid B which is oriented so that the principal plane makes an angle 45 degrees relative to B, sorry, relative to A. That means you have A and you have B like this. Okay, so A has path axis this and B has path axis along this direction. Okay, so this is 45 degree theta. Okay, theta is equal to 45 degree, right? Then what will be the intensity? I know after passing through this, intensity will be I0 by 2. Now here intensity will be I0 by 2 initial, along with that cos square 45 degree. So if this is cos square 45 degree, then it will be 1 by root 2 whole square, right? So it will be I0 by 4. So this will be the intensity of the light, emergent light. Okay, I hope you have understood this also. Just you apply Malus law. Now, at what angle of incidence the light reflected from glass be completely polarized? See, the question is from Busch's angle. See, we know for this, see what we know, let us write this. See, from Snell's law, I can write, see this is air, this is glass as said here, and it has intensity, sorry, refractive index 1.5, this is 1. So I can write mu1 sine theta b in this case is equal to mu2 sine theta. This is the refracted angle. Okay, this refracted angle is suppose some r. Okay, this is the bush. This is actually my this is angle of refraction. So say this is 90 degree. We can find out some relation between refracted angle and this. See, refracted angle, this reflected angle will be theta b anyway. So theta b plus 90 degree plus r, this will be actually 180 degree, right? So from here 90, here I can write 90, and then r will be 90 minus theta b, theta b. So if I just put it here, sine theta b mu 2 sine 90 degree minus theta b, that means this is mu 2 cos of theta b. Okay, theta b mu 1 sine theta b. So from here we can write, so mu 1 is actually mu 1 is 1, mu 2 is 1.5. So we can write mu 2 is equal to tan theta b. Okay, that means theta b, this is the Bouster's angle, so I have to find out tan inverse mu 2, right? Then what is mu 2? So we have to find out theta b. See, tan inverse mu 2 is 1.5. So I don't know, this question requires a calculator. So this will be around this much degree. Okay, 56.3. So this kind of question actually requires, if the angle is odd, then it is not possible to answer without the help of calculator. Okay, that easily. So therefore at least you just see this kind of question, the pattern, question of pattern, you can just see and you can understand how questions are coming from this polarization chapter. So that's the motivation behind choosing this question. Obviously in JEE and all, if question comes like this, uh, that is rare, because uh, this kind of angle finding without the help of calculator will be difficult. Okay, so for today this will be the last question, and that's how we'll be finishing this chapter. So let us see what is there in this. So two polaroids P1 and P2 are placed with their axis perpendicular to each other. That means this is one polaroid, okay, and another polaroid is this. But look, this case is, what is the situation? The situation is that path axis, it has path axis along y. Suppose this is x axis, okay, and this guy has path axis along x direction. So their path axes are perpendicular to each other. Okay, so some unpolarized light having intensity I0 enters like this, okay, and then after passing through this, okay, so let us first see what is again given. So this is P1, this is P2. Another polaroid P3 is kept between P1 and P2 such that it makes an angle 45 degree. So 45 degree to that of this. So look, this may be 45 degree. Okay, this is another polaroid P3 which has path axis making an angle 45 degree with the vertical or y axis. Okay, this is 45 degree. right? If this is 45 degree, along with this also it will be 45 degree here, right? So ultimately, see, after passing through, let me write P1, after passing through P1, intensity will be I0 by 2. After passing through P2, sorry, P3 here, now I0 by 2 cos square theta. That is actually 45 degree. That means it is I0 by 4. Okay, I0 by 4. Now, let me just erase this calculation part and write just simply I0 by 4. After passing through it, it is, the light will be I0 by 4. I have another polarizer, sorry, Polaroid 2, with which it makes an angle 45 degree again, like this, because this is the path axis for this P2. So then it has path axis like this. Then here it will be I0 by 4. Let me check, I0 by 2, then I0 by 2 cos square 45 degree. This was up to here. Okay, then another, so this is initial, and then another cos square 45, cos square 45. Okay, that means I0 by 4 and cos square 45 means half again, so it will be I0 by 8. Okay, so it is I0 by 8 is the answer. So intensity after transmitting from this P2 will be I0 by 8. Okay, this is nothing but Malus law. So this Malus law you have to apply carefully and solve this kind of problem. And as you uh, have seen throughout this classes, only two things from this, like only two things are important from this polarization chapter. That is, those are one is Brewster's law or Brewster's angle. Another another is Malus law related problem. Okay, so with this we have completed somewhat. This wave optics chapter will come up with new chapter again in the next class. So for today I'll stop it here. Thank you for your patience.